If you build a ship that's capable of going to Mars, well, what if you take that same ship and go from one place to another on Earth?
Starship is undeniably a groundbreaking invention in space exploration. However, its cargo capabilities could also revolutionize the military field. So why would a private spaceship attract military interest? How would Starship's role differ when used for military cargo purposes? All that and more will be revealed in today's episode of Great SpaceX. When we think of SpaceX's Starship, we often envision its role in space exploration, taking humanity to Mars and beyond. However, the US military has identified another potential use for this groundbreaking vehicle: Earth-to-Earth transportation. This concept involves leveraging Starship's incredible speed and capacity to enable ultra-fast travel between distant points on the planet, and it's a concept that makes a lot of sense. Upon closer examination, Starship is exceptionally well suited for this mission. The first factor that makes Starship ideal for Earth-based cargo transport is its unparalleled speed. Starship is designed to reach orbital velocities using its powerful Raptor engines. In the vacuum of space, where air resistance and weather conditions are non-existent, Starship can achieve speeds unattainable by any aircraft operating within Earth's atmosphere. The process is straightforward yet revolutionary. Starship would launch, reach orbital velocity, and then re-enter Earth's atmosphere to land at a distant location. For the military, this capability offers a game-changing advantage. It would allow for the rapid deployment of high-priority cargo, supplies, or personnel to any location worldwide, responding quickly to emergencies or dynamic operational needs. To illustrate just how fast Starship could be, consider Musk's 2017 presentation at the International Astronautical Congress, where he shared the video, Starship, Earth-to-Earth. It showcased a hypothetical flight from New York to Shanghai taking just 36 minutes. In comparison, a commercial airline would take 12 to 14 hours for the same trip. With Starship, most long-distance flights would take only under 30 minutes, and any location on Earth would be reachable in under an hour. Speed isn't the only metric that sets Starship apart. Its payload capacity dwarfs that of even the largest cargo planes. Standing at 121 meters tall and 9 meters in diameter, Starship is the most powerful launch vehicle ever built. It can carry 150 metric tons fully reusable and up to 250 metric tons expendable. For comparison, the Boeing 747-400, one of the most widely used cargo planes, can transport a maximum payload of about 113 tons. Starship's massive capacity could enable the transportation of military equipment, vehicles, and supplies in a single trip. This includes heavy artillery tanks or even helicopters. While Starship offers unmatched speed and capacity, there is one important consideration. Cargo destined for space travel must be pressurized to withstand the low-pressure environment of space. Without proper pressurization, the reduced pressure could cause air to expand, leading to potentially catastrophic failures such as bursting containers or even biological hazards for transported personnel. Fortunately, SpaceX has extensive experience managing pressurized environments. During the Polaris Dawn mission, SpaceX demonstrated its ability to maintain a safe, pressurized cabin, ensuring the safety of astronauts performing spacewalks. This expertise could easily be applied to Starship's design for Earth-to-Earth transport, ensuring the integrity of both the cargo and crew. Starship's combination of speed, capacity, and SpaceX's engineering expertise positions it as a transformative vehicle for Earth-based logistics. For the US military, it could mean unprecedented agility in responding to crises, supporting operations, or deploying humanitarian aid. While originally envisioned as a spacecraft for interplanetary travel, Starship's versatility opens up incredible possibilities for revolutionizing global transportation. Its ability to reach any destination on Earth in under an hour could redefine not only military logistics but also commercial shipping and emergency response. The future of Earth-to-Earth transportation may very well rest on Starship's sleek stainless steel shoulders. What do you think of this innovative concept? Could Starship become the cornerstone of ultra-fast global logistics? Share your thoughts and don't forget to like and subscribe to stay updated on SpaceX's groundbreaking developments. Indeed, Starship's capabilities for carrying cargo at speeds over 10 times faster than commercial aircraft are groundbreaking. But what about the cost? One of SpaceX's core design principles is reusability. Starship is designed to be fully reusable, including both the spacecraft and its booster, Super Heavy. This feature could make it particularly suitable for Earth-to-Earth payload transport, enabling frequent flights. Starship's ability to return, land, and be refueled quickly opens the door for multiple high-speed trips between global locations, accommodating both cargo and passenger needs. This reusability significantly reduces travel costs compared to current commercial space vehicles, which often require extensive refurbishment or rebuilding after each flight. Over time, as infrastructure improves, Earth-to-Earth transport with Starship could become far more affordable. Fuel costs are another critical factor. A single Starship launch currently costs about $900,000 in fuel, which is higher than jet fuel costs. However, the primary reason for this is that SpaceX does not yet produce its own fuel. To address this, Musk, alongside another contributor, committed $100 million to the X Prize competition for innovative carbon capture and storage, or CCS, technologies. With this technology, SpaceX aims to produce liquid oxygen and methane internally by capturing CO2 from the atmosphere. If successful, this approach could drastically lower fuel costs while addressing environmental concerns associated with methane usage in Starship. For those concerned about the high costs of shipping goods via rocket, there's another method specific to Earth-based point-to-point missions that could further reduce expenses, using only the upper stage of Starship. In discussions on X, Musk suggested adding 2 to 4 Raptor engines to the Starship upper stage for these missions, enhancing its single-stage-to-orbit capability. This modification would boost cost efficiency and simplify operations. It would allow long-range missions of approximately 10,000 kilometers at speeds of Mach 20, all while maintaining substantial payload capacity. Additionally, using only the upper stage would significantly reduce noise during takeoff and landing, making operations in urban areas like major cities more feasible. These cost-saving measures make Starship highly competitive compared to existing rockets. While not yet fully operational and with some uncertainties about exact costs, SpaceX aims to reduce launch expenses to $2 to $3 million per flight. Achieving this goal would make Starship one of the most cost-effective launch vehicles available, particularly for large payloads. Moreover, Starship's potential to outperform other rockets in cost per kilogram to orbit is significant. For high-capacity and frequent missions, this vehicle could redefine what is achievable in both space exploration and terrestrial logistics. With its groundbreaking combination of speed, reusability, and cost efficiency, Starship is poised to revolutionize not just space travel, but also global transportation. With its revolutionary capabilities, it's no surprise that the U.S. military is highly interested in SpaceX's Starship. The Department of the Air Force is actively exploring the use of rocket cargo transportation for Department of Defense logistics. In alignment with commercial advancements, the Air Force Research Laboratory is evaluating emerging rocket technologies from various vendors to assess their feasibility for rapid global material transport. In 2022, AFRL awarded SpaceX a 5-year, $102 million contract to collect flight data from Starship to demonstrate technologies for point-to-point cargo and humanitarian aid transportation. According to AFRL, logistics speed is at the heart of military supremacy. The organization recognizes that if a commercial company like SpaceX is advancing capabilities to move materials faster, the DoD must engage early and explore adoption opportunities. This motivation underpins the Rocket Cargo Program, a forward-thinking initiative aimed at leveraging Starship's unique attributes for military logistics. Gary Henry, Senior Advisor for National Security Space Solutions at SpaceX, discussed this interest during the 2024 Space Mobility Conference in Orlando, Florida. He highlighted specific use cases where the DoD might require Starship's capabilities. It really came down to specific missions where it's a very specific and sometimes elevated risk or maybe a dangerous use case for the DoD, Henry explained. He noted that the DoD has considered whether such missions necessitate owning a similar asset or if SpaceX could accommodate their needs. The Space Force has also been closely monitoring Starship's progress. Notably, General Chance Saltzman, Chief of Space Operations, was present at Starbase, Texas, to observe the 6th flight of Starship. This demonstrates a high level of interest and engagement at the leadership level. Lieutenant General Philip Garrett, commander of Space Systems Command, has also spoken about Starship's potential. In a roundtable with the Defense Writers Group, he remarked, "We are thinking about how we might use it. The first most logical use, given the payload volume, would be some type of rocket cargo delivery mechanism." He emphasized the Space Force's keen interest in Starship's military utility and their close tracking of its development. Starship's ability to rapidly transport large payloads globally could transform military logistics, making it an invaluable asset for both strategic operations and humanitarian missions. While Starship's groundbreaking capabilities in payload capacity, reusability, and interplanetary travel are clear, significant challenges remain before it can serve as a viable solution for global high-volume cargo delivery. The most significant obstacle is regulatory compliance. Starship must meet national and international aviation and space regulations from organizations such as the FAA, ICAO, and other regional authorities. Concerns about air traffic management, safety protocols, and compliance with flight regulations are critical. Furthermore, environmental issues including carbon emissions, rocket exhaust pollution, noise, and potential damage to the ozone layer will face intense scrutiny from both environmental agencies and the public. Routine, large-scale launches would require rigorous environmental assessments to gain approval. Beyond regulations, practical issues regarding Starship's payload capacities present challenges. While it can carry massive payloads, not all cargo types are suited for its unique design. Large or bulky items might not be an optimal fit within the cargo bay or could require specialized handling incompatible with spaceflight conditions. Additionally, Starship's vast capacity may be excessive for smaller or low-value shipments, reducing its cost-effectiveness in such cases. Truth be told, establishing a truly global cargo delivery system would require significant infrastructure investment. SpaceX would need to develop a network of spaceports and logistical hubs worldwide, a process requiring substantial time, capital, and international collaboration. Scaling this operation while maintaining reliability, efficiency, and safety would add further complexity and costs. While Starship holds immense promise, overcoming these hurdles will be essential before it can revolutionize global cargo delivery. Its ultimate success will depend on innovative solutions to these challenges and continued cooperation with regulators and stakeholders worldwide. And with that, thank you so much for tuning in to today's episode, and as always, this has been Kevin from Great SpaceX. Until next time, keep looking up.